There is an example of when you would use the goodness of fit test to test the hypothesis that all categories are not equal. So we'll just keep it very, very simple here. Everybody, I'm sure, can relate to this. You might have noticed that in a lot of your psych classes, the majority of the students in the room are female, right? I don't know if you've ever noticed that. Contrast that to, let's say in the engineering department. If you were to go into one of their classrooms, you would notice that the majority of students in the room happen to be male, all right? So it's kind of interesting that the majority of our psych majors are female, because that's not how psychology started out, right? Psychology was mostly a male-dominated profession. And it's only in the last few decades that we began to see the shift from male to female. Anyways, that's just a little bit of history about this example, but here we go. Okay, so let's say you have a large 10-10 class, or, well, those wouldn't be psych majors. Well, you have a large class. Let's say it's a really large statistics class. So it's not at SUU because we have small classes. But you go into this classroom and you count. So these are the observed frequencies because it's you counting them. You're observing them. You count 42 men in the room and 68 women. All right? Now, that difference could be just sampling error, right? This could be nothing more than a fluke. This is what we would expect to see, in the sense that we're going to see a difference between the number of men and the number of women. All right? It's not likely in a huge classroom like that we're going to get an even split. But the question is this in fact just a chance observation, right? That really, statistically, these two numbers are the same. These two frequencies are the same, right? So you want to know if what you have is just sampling error, or is it sampling error plus something else? So to find out, you're going to do a chi-square goodness of fit test. Now, the goodness of fit test that you're going to use is going to, again, allow you to figure out whether or not this 42 is statistically equal to the 68. So what the chi-square test will do is it will calculate what you should have seen for men and women if, in fact, the two were the same, all right, evenly distributed. So how do we know that it's 55 and 55? Well, if you add up 42 and 68, you get 110. All right, so if there's 110 people in the room and the frequencies are evenly distributed, then we just divide that in half and say, okay, so there should be 55 men and 55 women. So that's what we're going to do. We're going to, well, SPSS does it automatically, but it's going to calculate the expected frequency that way. If we had a third category, let's say non-binary, then it would take the 110 people who are in the room and divide it by 3. All right, and then you would get your 3 categories, your expected frequency for the 3 categories. Okay, now when you do the chi-square test, okay, after it calculates expected frequencies, what's going to happen is the test is going to compare what you found, so in other words, 42 and 68, against what we should have found if, in fact, the frequencies were the same. Okay, let me repeat that. The chi-square test is going to compare what we found, what we observed, to what would be expected if, in fact, the frequencies were evenly distributed. So, HO is going to say that the frequencies we observed are the same as what we expected. F observed equaled F expected. In other words, our distribution of men and women, the 42 and the 68, are statistically the same as 55 and 55. All right? Now, in words, we could say, because we could say it like this, or we could say that male and female psych majors are equally represented. Same number of male psych majors as female psych majors. HO is going to say these two sets of frequencies are not the same. So notice it's non-directional, right? We're not saying observed are going to be greater or less. We're just saying that they're going to be different. Okay, so F observed are not going to be the same as what we expected. And what would that tell you? All right, well, we would write it out this way. Male and female psych majors are not equally represented. All right, so it's saying that either there are more males than females or vice versa. We are not going to include that in our hypothesis. We're just going to say that the distribution of male and female, so the number of males and the number of females, is not the same. Okay, so the chi-square test is going to give you a chi-square value, a number, because after all, chi-square is just a test statistic. And so you're going to get a number at the end, and then you're going to see whether or not that is a significant result. Is that number high enough for you to claim it's significant, in which case you're going to reject HO, right? Remember that? Right, so if chi-square is not significant, in other words, if the sig value is 0.05 or greater, means our chi-square is not significant, what would we conclude? Well, it means, first of all, that we are going to retain HO, right? Not significant, null, not a nothing, retain HO, which means that our observed frequencies, 42 and 68, are statistically equal to the 55 and 55. So we would conclude that whatever difference we think we're seeing here, that's probably just sampling error. And there really is no difference between men and women. In other words, men and women are equally distributed in the classroom. All right. Now, on the other hand, if chi-square is significant, so the sig value was less than 0.05, that means we are going to reject HO, and we're going to conclude that the two sets of frequencies are different from one another. In this case, we're going to say that male and female psych majors are not equally represented. Probably, right? Always add that word, probably. They're not equally represented. Now, you wouldn't want to stop with that conclusion and move on, because you've just left me with a cliffhanger. Okay, so they're not equally distributed, but then who occurs more often than the other, right? Which sex appears more often? And so we would conclude that it's probably the case that there are, in fact, more female psych majors than male psych majors. Okay?